Today, we are going to look at hydrocarbon. Okay? Hydrocarbon is the compound that contains carbon and hydrogen only. Okay? Hydrocarbon is the compound that contains carbon and hydrogen only. Okay? The carbon and hydrogen in the organic compound occurs naturally, as we discussed in the last video. Okay? Then the hydrocarbon can exist either in gaseous state or in liquid and solid states. Okay, that means hydrocarbon can exist in three states of matter. It's either it exists in gaseous states or in liquid states, or it can exist in solid states. Now, let's look at the classification of this hydrocarbon. Classification. All right, that is the class. Hydrocarbon is classified into two. We have here as aliphatic hydrocarbon. Here is aromatic hydrocarbon. Okay? Hydrocarbon are categorized into aliphatic hydrocarbons and aromatic hydrocarbons. Okay? Aliphatic hydrocarbon possess straight or branched chains or ring chain hydrocarbon. Okay, they possess either straight chains or branched chain or ring chain hydrocarbon. Okay, they have a straight chain or can have branches. You understand? It have either straight chain or branched chain hydrocarbon, or it can have a ring chain, just as we have in aromatic. It can have ring chain like this, which we looked at in the last video. Now, that means aliphatic hydrocarbon can be divided into two based on their chains. The one that have straight chains are known as acyclic, while the one that possess ring chain are known as cyclic. Now, that means aliphatic hydrocarbons can be divided into two. We have here acyclic and cyclic. Based on their chains, aliphatic hydrocarbons are categorized into two. Okay, let me put it this way. Aliphatic hydrocarbons categorized into two. This is based on their chains. Based on their chains. And here is based on their saturation. Based on their chain, aliphatic hydrocarbons are categorized into acyclic and cyclic. Based on their saturation, aliphatic hydrocarbon are categorized into saturated and unsaturated, okay, based on their chains. The one that have ring chains are known as cyclic, okay, that means they possess circular shape. Then the one that is straight chain or branched are known as acyclic. Then here, aliphatic hydrocarbons are categorized into two based on their saturation. The one that is saturated is saturated hydrocarbons. Then the one that is unsaturated are unsaturated hydrocarbons. That is to say, we have saturated and unsaturated aliphatic hydrocarbons, then acyclic and cyclic aliphatic hydrocarbons. Okay, all these are what we have under aliphatic hydrocarbons. Now, examples of saturated hydrocarbons here, we have only one example known as alkanes. Alkanes is the only saturated aliphatic hydrocarbon. Then unsaturated here are alkenes and alkynes. Okay, alkanes are saturated because they have single covalent carbon-carbon bond. Okay, then alkenes are unsaturated because of the presence of weak bond as a result of possessing double covalent carbon-carbon bond. One of the double covalent carbon-carbon bond is a sigma bond, which is a very strong bond, while the other is the weak pi bond. Because that bond is very weak, that is why this pi can undergo reaction easily. It is said to be more reactive than alkanes because of the presence of the weak pi bond. This is sigma bond. Here is the weak pi bond. The bond is weak. The bond is strong. All right. Then here is a very strong bond, which is a sigma bond. Okay. One sigma bond, one pi bond. Okay. Here we have triple covalent carbon-carbon bond. Okay. One sigma, two pi bond. Okay. Let me write it here. One sigma and two weak pi bond. Okay. Then on that note, alkynes here is the most reactive because of the presence of the two weak pi bond. All right, it can undergo reaction more readily, more easily than alkenes. Alkenes, which is more reactive than alkanes. Alkanes are reactive, but is very less reactive. Another name for alkanes here is paraffin. Another name for alkanes is paraffin. I'm going to describe this in the next video. I will tell you the meaning of paraffin. Please don't forget. So that is all on saturated and unsaturated hydrocarbon. Now let's look at acyclic. Acyclic. Acyclic are the straight chain hydrocarbons. They are straight chain or branched. Okay? These are straight chain hydrocarbons. These are straight chain or branched chain hydrocarbon. Then cyclic. Cyclic, these ones are the one that possess ring shape. Cyclic are the hydrocarbons that possess ring chain. Okay? It's either they are like this becomes cyclopropane, or like this. Here is cyclobutane. Here becomes cyclopentane. And finally, here is cyclohexane. This looks like benzene ring, but there is no double bond. So this is saturated hydrocarbons. Okay, all these ones are saturated because they possess single sigma bond. That is single covalent carbon-carbon bond. Okay, that is to say, in essence, that these saturated hydrocarbons can be cyclic and acyclic. It can be cyclic or acyclic, but I just differentiated the two based on the shape of the chains. All right, so you can classify aliphatic based on their chains as acyclic and cyclic. All right, but this saturated can also be cyclic and acyclic. So if they possess single bond, it becomes saturated. All right, if they possess double or triple bond, they become unsaturated. All right, now aromatic hydrocarbons are those hydrocarbons that possesses benzene ring chains. All right, they possesses benzene ring chains. All right, or they possess the same structural formula of benzene. Okay, or you can say they have the same structural formula of benzene. Example are benzene, anthracene, and naphthalene. These are other examples of aromatic hydrocarbons. Okay. Now, we're going to look at alkanes, okay, in the next video. Please don't forget to subscribe to the YouTube channel, right? Wait for the next video.